Okay, this is chapter 4, lesson 2, and it's called Translating Graphs of Sine and Cosine. And translating is going to mean move a graph left or right or up or down. And this just follows what we did in section 1 where we found out how to change the amplitude of a graph, make it go up higher or lower. We found out how to make a sine or cosine graph occur more frequently or less frequently by changing the period. And now we're going to move these up and down, left and right. So we're going to start with a vertical shift. And let's just compare. You can probably, your intuition is probably pretty good on this. Let's look at sine of x. Let's look at sine of x and see what happens to the graph when we add on 2. So just in your mind, maybe you're thinking of that, what happens to that. And let's just check it here and see. Let's put in sine of x. Let's put in sine of x plus 2. Or if I put in 2 plus sine of x, that'd be the same thing, right? And let's graph that. For a window, I can choose my window, or if you have a graphing calculator, if you hit zoom, look at number 7, zoom trig, which is usually a really nice window for trig functions. So we'll come down there. One more, zoom trig, and let's graph sine of x and sine of x plus 2. There's sine of x, kind of what you expected, I hope. And there's sine of x plus 2. All right, so let's keep that. And so we've got our 2, let's put it over here, I suppose. So we've got sine of x plus 2. And what does the sine of x plus 2 do? Well, it takes your whole graph, and everywhere it raises it up 2. So we make a conclusion here. It raises the graph up. It raises it up 2 units. Okay, seems to be very straightforward. Let's just look at one more to hopefully confirm that. Here's cosine x. Here's cosine x minus 3. In your head, are you seeing a cosine graph? And now you're seeing a cosine graph, and you're thinking that cosine graph is going to get shifted up or down. Are you thinking it's going to get shifted? Well, let's see how it's going to get shifted. So let's go, here's cosine x. And here minus 3, so I'm going to go negative 3 plus cosine x. I could have written it cosine x minus 3 also, but just to show you, here's another way to say the same thing. We'll keep our same window, so I'll just go right to graph. And that looks like a cosine graph. And that looks like a cosine graph. And the whole thing shifted down 3. Okay, so conclusion on that. Graph was shifted 3 units down. So we're shifted down 3 units. So everything in that graph down 3. So this looks nice and straightforward. And by itself it is, but remember we did 2 things in the first section. Now we have a third thing. We're going to add another thing. There's going to be 4 different ways to shift these graphs. It's going to get very, very complicated. But our first part we've got here is called the vertical shift. It's the amount the graph is shifted up or down. And how do you do this? Add a constant, and add that constant in the front or the back of the function. So look down here, we've got y equals 4 plus sine of x. Would you agree that shifts the graph up 4 units? Or here's negative 3 plus cosine. We just did that one, didn't we? So that one is down 3 units. Okay, one of our 2 ideas is complete. How do we shift the graph up or down? We've got it. Add something on or subtract something to the whole function. Now let's get our second kind of a shift. It's a left-right shift, so it's called a horizontal shift, or they'll call it a phase shift. And I think the book more frequently uses phase than horizontal. So let's just check this again and see. Here's sine of x. And now let's add something on, but notice what we're adding on is inside the parentheses. We're going to add on a pi force inside the parentheses, and let's see how that shifts the graph. I guess it's in the phase shift, so you're probably thinking it's going to shift it left or right. And we'll see what your intuition tells you on this one. So let's graph sine of x, and then let's graph now the sine of x. And let's, oops, no, 2 x's there, sorry about that. Sine of x, and let's graph, add on, so plus, let's add on pi force. And again, the pi values make sense on the x-axis, because remember we label those 0, pi halves, pi, 3 pi halves, and 2 pi. So it kind of makes sense for our phase shift to add on in increments of pi, so some multiple of pi or fraction of pi. So here's sine of x plus pi force. keep our same window, and let's watch these. Let's actually make the second graph darker, just so it's a little easier to tell which is which. Make that darker. All right, let's hit graph and see what we've got here. Here's your sine graph. Looks like our regular sine graph. X plus pi fourths. And it moves it. It certainly moved it left or right. And you could argue, well, I think it moved it right. I think it moved it left. It turns out a plus pi fourths takes the whole graph, our regular sine graph is here, and it's shifting it to the left. And right there would be pi fourths. So a plus pi fourths, so plus pi fourths shifts, maybe not the way you were thinking. It shifts it left. Shifts left by pi fourths units. Okay? So it looks like inside the parentheses it's going to shift it left or right. And when it's a plus in there, it shifted the graph to the left. If you think back to advanced algebra, algebra 2 trig, when you did equations of circles or any of the conic sections, parabolas, hyperbolas, ellipses, if you had some kind of an equation like this was the equation of a circle, and how was the center changed? Well, it was changed right 4, and it was changed down 2. So it's very, very consistent, this phase shift. It's very consistent what you were doing in algebra 2 with your conic sections. So a plus pi fourths shifts it to the left pi fourths. Okay, let's just verify and make sure that actually works for other things. Here's a cosine of x minus pi thirds. Are you thinking now left or right? And you're thinking hopefully what I'm thinking. Let's see. So here's cosine at x, let's go minus, and we've got a pi thirds. Oops, and I'll take out that extra plus sign. So we have cosine of x minus pi thirds. Let's hear the graph. Here's our regular cosine graph. Looks good. Minus pi thirds, look at that. It takes the whole graph and it picks it up and moves it to the right pi thirds. Oops, that may be a little too big there. But it shifted it, so minus pi thirds is going to shift it. So this is our conclusion. It goes to the right by pi thirds units. Okay, I think you've got this, but I want to show you one more just because it's kind of interesting. And it's something you may have realized before, but let's look at, oops, I covered it up, sorry. The thing I'm interested in actually is the sine of x minus pi halves. The 4 is kind of nice because remember what we did previously? What is the 4 going to affect? Thinking amplitude? So we'll look at that, but then this minus pi halves is kind of interesting. So take this out, take this out. Oops, try that again. Take that out. And let's go 4 sine at x minus pi halves. Let's look at this graph. Are you expecting to go up and down 4 now? Look at that. It sure does. And I get that answer. And actually, oh yeah, let's keep that one. I get that. So I see the 4 in here. But somebody could look at that graph and I would say, you know, is that a sine graph or a cosine graph? Couldn't you see somebody saying, wait a minute, that doesn't look like a sine graph. This looks like an upside down. That looks like a negative cosine graph. This looks like negative 4 cosine x. And it turns out they would also be correct. So it turns out sine graphs and cosine graphs really are the same thing, and you can shift, and I'll be on homework questions, you can shift a cosine graph to make it coincide with a sine graph, or a sine graph and make it coincide with a cosine graph. So you start to see, it's like, wait, this looks like an upside down cosine graph. So this pi halves shifted it just enough, so now all of a sudden it looks like a cosine graph instead of a sine graph. So a conclusion on this one, shifted it to the right. It shifted it to the right, pi halves units. And also the amplitude, it goes up to 4. Count the units, 1, 2, 3, 4, up to 4. Look at that, down to negative 4. All right, so let's just summarize what we have here. And then let's try, we're going to break this into 2 parts. Today's part I think you'll find kind of easy. We're just going to read off the parts of the equation. And then tomorrow, once we've read off those parts of the equation, we want to practice the graphing of it. Okay, so we've got our phase shift here, our summary. Phase shift is you mount the graph to shift it to the left or right. How would you do that? Shift it left or right? Add or subtract, but it's within the function is where you're adding or subtracting. Shifts it left or right. So now, between section 1 and section 2, there are 4 different things you can do to a sine graph or to a cosine graph. You can multiply by something in front. You can multiply by something on the inside. That was section 1. That affects the amplitude and the period. And now the new things today, you can add or subtract something on the inside. You can add or subtract something at the beginning of the function or at the end of the function. That's true for sines and cosines. So understand, the number in front that's multiplied here, that A, that affects the amplitude. That is the amplitude, I'm sorry. B will affect the period. B is not the period. If 3 is in there, the period is not 3. It's 2 pi divided by whatever that number is, but it certainly has an effect on the period. C, the number at the end or at the front that you add or subtract on, that's a vertical shift. And the number on the inside of the parenthesis with the X, that's your phase shift. And always remember that one is the one that goes opposite of the sign. So a plus shifts it to the left, a minus shifts it to the right. Okay. Let's see if we've got this and if we can sort through all these things. So the homework is going to read, find the amplitude, period, phase shift, vertical shift, and sketch the graph. This part we hold on to today. We're not going to do any of the sketches today. That part will come tomorrow. If you can see how you sketch the graphs, good for you. You can go ahead and get ahead. All right, so let's look at number 1. I see a 2 here, and I see a pi here. You might want to flip back in your notes and see, wait, what are those 2? The 2 in the front, that is the amplitude. So I'd say the amplitude is 2. And then in here, the parenthesis with the x, the minus pi, is your phase shift. It's going to go pi, and since it's minus, it's pi to the right. So we've got our amplitude, we've got our phase shift, and there is no period change. So the period will be our normal 2 pi. That's our normal period for a sine or cosine. And the vertical shift, there is none, so we won't mention the vertical shift because it's 0. So the period doesn't change, it's 2 pi, amplitude is 2, phase shift is pi to the right. All right, next one, very similar. We have a 2/3 in front. I was thinking that's the amplitude. In here with the x, we have a plus pi halves. That's our phase shift. So it's going to be pi halves. It's a plus. So we take this graph and shift it pi halves to the left. What's the period? Doesn't change. 2 pi. Vertical shift? None at this point. All right, a couple more of these. Ooh, add on another number in here. We've got this -2 out in front. That's our vertical shift. And it's a -2, so we're going to go down 2 units. The rest is similar. We've got our 3, that's our amplitude. So our graph goes up to 3 and down to 3, and you can start thinking how you would graph that. Which do you do first? Do the amplitude first or the vertical shift first? We'll talk about that tomorrow. And then our pi is our phase shift. This can be pi, it's a plus. So pi units to the left. All right, seems like you've got this, hopefully. Then all of a sudden there's a little bit of a trick in here in number 4. If we go back to our formula, we'll see the difference between the way this is written and the way our formula is written. So here's our formula. And notice in our formula, they factor out this number, and it's x by itself, x minus d. All right, they have not distributed that. Whereas in the problem we have here, you'll see it is distributed. So it's a little bit of a subtlety. But what we want to have here is I want to write my 1/2. I want my cosine. But I want to factor out that half and have just the x. And what does pi force become if you factor out a half? Well, it was pi force. When you factor, it's like dividing. So I want to divide by 1/2. But wait, dividing is like multiplying by the reciprocal. So pi force times the reciprocal times 2 is going to be 2 pi force. I know I could have cross-canceled. Or pi halves. So when I factor out this half, this becomes x minus pi halves. And hopefully that makes good sense to you because look, if you distribute it back in there, sure enough, you'd get your pi force. So I have to write it in this form. And once it's in this form, I can see what's the amplitude? 1/2. What's the phase shift? Looks like it's pi halves to the right. And now finally I've got a number in there with the x, and it's a 1/2. So the period, normally it's 2 pi. I divide by that number. I divide by the 1/2. How do you divide? Multiply by the reciprocal. And so the period now is going to be 4 pi. This graph is going half as quickly. It's going to take twice as long. So instead of 2 pi, the period is now 4 pi for this graph. Alrighty, guys, and it looks like I'm over here. These other two are very, very similar. Let me just give you the answers real quick, and you can check them or ask questions if you have it. This is going to go down 4 for the vertical. The amplitude is 3. The period is just our normal 2 pi because in front of the x there's a 1. And the phase shift is pi halves left. Last one, up to. This negative affects the amplitude. It's going to flip the graph over, but this is a positive 2 there. The amplitude, is still 3. The negative will deal with in the graph. The period is 2 pi divided by 4, so it's pi halves. That graph occurs more frequently. And the phase shift is pi thirds. And again, it's a plus, so that'll shift it to the left. So that completes the first part of this.